Welcome everyone. So on internet on YouTube, I often see these type of problems that 7 power 100 is greater or 100 power 7 is greater, or you can say 3 power 9 90 is greater or 90 power 3 is greater. Sorry, what did I write? 90 power 3 is greater. So, well, to answer these type of questions, let us dive deep into the general idea behind these problems and see can we come up with a general solution or not. So let's see, we have numbers like a raised to the power b and b raised to the power a. Can we just look at these numbers and tell without solving whether who is greater than whom? Yes, we can do that. We can do that. Welcome everyone. So today I am going to deal with these type of problems that I often find on internet, on YouTube, that things like numbers like 8 to the power 19 is greater, or 19 to the power 8 is greater, or you can say 100 to the power 7 is greater, or 7 to the power 100 is greater, or things like that. Okay. So of course we can solve these questions, we can use some tricks and find out who is greater and who is smaller. But what is the general solution of this problem? Can we just look at this type of problem and tell which one will be greater without solving? Just there is a way to tell who is greater and who is smaller. So I am going to dive deep into the problem and understand the mathematics behind these type of problems. So let's see, let's begin the problem and see what's going on here. Is we have a number a raised to the power b and we have b raised to the power a. So we can do one thing here, we can raise to the power 1 by ab on both sides. Since a and b are greater, so we greater than 0, so we can do that. So now the equation, the quantity will become 1 by a here and b raised to the power 1 by b here. So now the equation is reduced to this form. Let's talk about one of the numbers of this form. Let's suppose we have a function which is of the form x to the power 1 by x. I am interested in understanding this function now. So let's understand this function. So for that we need to differentiate and we need to find the maximum value and so on. We need to graph it and see on the graph what the function has to say. So let's take log on both side, log base e on both side. So we will get log e of x to the power 1 by x. So this will be converted as log base e of y is equal to log 1 by x let me please write it down again, 1 by x log x. And now we can differentiate it, and here on the left hand side you will get 1 by y times y dash, and y dash is the derivative, is equal to derivative of 1 by x and log x plus 1 by x derivative of log x. So we have used the product rule, simple product rule. So now we are getting 1 by y dash is equal to, now 1 by x, derivative of 1 by x is minus 1 by x square log x, and plus 1 by x, and derivative of 1 by x, sorry, derivative of log x is 1 by x. So now you are getting something like minus 1 by x square log x plus 1 by x square, or you can take 1 by x square common, so you will get 1 minus log x inside the bracket. So finally rewriting the equation in a derivative form, you get y dash or y prime is equal to y times 1 by x square times 1 minus log x, or y was x to the power 1 by x over x square, and you have 1 minus log x, and now you have this quantity equals to y dash. Now in order to check the maximum and maximum values and critical points and all, we need to equate this equation equal to 0. So y prime should be equal to 0. This gives us x to the power 1 by x and x square over x square 1 minus log x is equal to 0. Now carefully see that this quantity here is always greater than 0, because x is greater than 0, so x to the power 1 by x is greater than 0 and x square is also greater than 0. So you can now say that since this quantity is greater than 0, so only this quantity can be equal to 0. This quantity can only be equal to 0. So this will give you 1 equal to log x base e on base e. So x is equal to e. Now let's see what's happening at x equal to e. So on a number line, here suppose e is here. So we want to check what is going on the right hand side of the e and on the left hand side of e. So let's take a value from the right hand side of e, from this side. So obviously the value will be greater than e. So let's take a value e square and put x equal to e square in the above differential equation. This derivative y dash is equal to x to the power 1 by x by x square and 1 minus log x. So since this quantity is already positive, so we need not to worry about this quantity, because it will always be positive no matter what value of x, what positive value of x you are putting. So now let's see, you have this quantity here, x to the 1 by x over x square, and you have 1 minus log e square. Now 1 minus log e square is 1 minus 2. So this whole thing will become negative, less than 0. So on the right hand side of e, y dash is negative. And if y dash is negative, then the function is decreasing. Fx is decreasing. And you can check for the left hand side of e, and it will be increasing. See, let us take a value of e which is let us take a value which is smaller than e. So I am going to take some value here which is e inverse, which is smaller than e, and put it in our equation. Y dash is equal to x1 by x over x square, and then you have 1 minus log e inverse. So this quantity will give you minus 1 and minus 1. So whole thing will be positive. So now I am redrawing our number line and see what it tells us. So it's e here. For right hand side we have y dash negative, and if y dash is negative, fx is decreasing, and for y dash is positive here, or you can say simply positive. So you will have increasing function here, fx will be increasing. Now let's draw the graph of these function. So somewhere here it will be e, this is 1, this is 2, and this is 2.71 something, which is e, and this is 3, and so on. So actually the function is not defined for negative values. So I will start from here, and we will start like this. The function will increase, go on increasing, and then reach the maximum point here, and then it will start decreasing, and it smoothly decreases and goes to infinity. So this is how the function should look like. So this is the graph of y is equal to x to the power 1 by x, and the maximum value of y is e to the power 1 by e, maximum value. From the graph we can see this is the maximum value, which is e to the power 1 by e. So now we are done now, and if we take some number a here and some number b here, then we will say that according to the function fa is equal to y is equal to fa is equal to a to the 1 by a power 1 by a. So its value will be here on y axis somewhere here, which is a power 1 by a, and we have b here. So I can write value of b as fb, y is equal to fb is equal to b 1 by b, which is here. Now see, a is smaller than b, but the value of fb is greater than value of fa is greater than value of fp, because it is decreasing function. So in decreasing function, always remember, if x1 is smaller than x2, then fx1 will always be greater than fx2. So it means that a power 1 by a will always give greater value than b power 1 by b, or simply put, a power b will always give you greater value than b power a. Okay, if a is less than b, if a is less than b. So now we have established this result here, which holds true for all such values of a and b. What does it mean? It means let's check our result for small values. Let us take some value of a, and remember a and b are all both on the right hand side of e, so it should be a and b should be greater than a and b should be greater than e, which is 2.71 something. So let's take a is equal to 3 and b is equal to 4 and check whether 3 power 4 is greater and 4 power 3 is greater. Now obviously if we follow our result, we can say directly that 3 power 4 will be greater. Now let's check it. It is 81 and this is 64. So which holds? Very good. Now, but what happens if we have a and b on the left of a and b on the left of e? See, if a and b are from this portion, what will happen? Since a and b are on the left hand side of e, and on the left hand side of the e, the function is increasing, and in an increasing function, we can simply see from a graph of increasing function. Suppose this is an increasing function. Okay, so here let us take one value x1 and one value x2, and this value will give you some value of the function y1 at y1, and some value it will give here y2, and we can easily see if x1 is greater than x2, then y1, sorry, if x1, sorry, I have written it incorrectly, apologies for that. I should write x1 is smaller than x2, then y1 is smaller than y2. It means that if x1 is smaller than x2, then fx1 is smaller than fx2. What does it mean? Now what is our function x1 of what is fa should be smaller than fb if a is smaller than b. This means this result, and it means a to the power 1 by a will be smaller than b to the power 1 by b, or you can say a to the power b is smaller than b to the power a. So the function is behaving just opposite to what it has behaved for a b greater than e on the right hand side of the e. So now you have, if a less than b, then this will happen. Now let us test our result. Let us take two values which are less than e. A and b are smaller than e and they are positive. So we can say that, let us take a is equal to 1 and b is equal to 2, because e is 2.71 something. So we can say 1 power 2 and 2 power 1, which is greater? This is greater. See, here 2 is greater than 1, 2 is greater than 1, that is why 2 power 1 is greater than 1 power 2. We can take another example. Let us take two values. Let's take 0.5 and let's take 2. Okay, so we know that 2 is greater than 0.5. So what about 2 to the power 0.5 and what about 0.5 to the power 2? So according to the analogy, this should be greater. Now let's check. 2 to the power 0.5 is root 2 and 0.5 to the power 2 is 0.25 and root 2 is 1.41 something, which is greater than 0.25. So now we have talked about the left hand side of E and the right hand side of E. We have talked about these two sides. Now one case is remaining if A and B or are on the either side of E. Then what will happen? So in that case we cannot decide, because if one part of the value is from this side and one part is from this side, so you cannot decide whether which is greater than what. Why? Because function is neither increasing nor decreasing, or you can say function is increasing and decreasing both, so you cannot use these conditions. These conditions we cannot use here. So so we have decided a pretty good establishment of our results for these type of problems, and you can now just by looking at the problem you can tell which is greater. So here A and B are both greater than E, so you can easily say this quantity will be greater than this quantity, and here also you can say that this quantity is greater than this quantity. This is greater, this is greater, simply. So I hope you have understood the explanation. If you have something to add to my explanation, please let me know in the comment box. I'll try to incorporate it, and if you have something to add, let me know. Thanks everyone for watching the video.